Okay, cool. We're going to start with homework 6, part 2, the last of the homeworks. That's not optional. And I'm going to start by just running all the code we had up until the end of last lab so that we have all of our data loaded and all that. Okay. First thing we might want to check is if our data list is still correct. Things I'm looking for here are the amount of rows and columns, are each of the elements named correctly, trip data. Yep. Weather data, all that looks about right. So let's get started with the prompt. Part of part 2, it says identifying trip regions. The terminal, to station ID and from station ID columns in data list station data and data list trip data have a 2 or 3 character code followed by a hyphen and a numeric code. These character data codes convey the broad geographic region of the stations. Things like CBD is Central Business District, PS is Pioneer Square, ID is International District. Write a function called region extract that can extract these region codes by taking a character vector as input and returning another character vector as output. That just has the 3 initial character codes, or has these initial character codes. There aren't always 3 initial. For example, if I run region extract on this vector here, it should give me an output of a character vector with the first entry CBD and the second entry ID. Note, if you cannot get this working and need to move on with your life, try writing your function to just take the first 2 characters using string sub and use that. I take it that if you have time to either be here or watch this back, you're probably not going to be in this group, but you might. So we'll cover that as well. Okay. Let's get started. We want to look at my notes. Okay, so we want to write a function called region extract to deal with the codes in our data. So I'm gonna see what they look like in the data so that we can have a sense of them. So here I'm just gonna run a glimpse on one of our data frames where we know they have these codes, and they'll have things like BT-01, BT-03, BT-04. And we also know from the prompt that some of these are longer than 2 characters. BT being Belltown, if you're wondering. Let's see. Before we get started, I feel like there's something else we needed to do. I'm just going to reiterate here that we're going to use the stringer library. I'm going to make sure that I have that. I know that I've already run all of this code and it necessarily had stringer at the top, but if you're watching this back and maybe missed that step, that's there. Let's see. We want to write a function called region extract. How do we get started doing that? We know it's going to be called region extract. What next? I know we talked about making functions a little while ago, but what's the first step into making a function? What function makes functions? Yeah, the function makes a function. And what happens? What's the first thing we type inside of our function call? Yes, the thing that we're going to like input into our function. So region extract can take an argument. Let's just call it x for now. And then we're going to use these little squiggly brackets, which will make the body of our function. All right. So before getting started on or creating a region extract function, what are your ideas for how are we going to extract these values? Let's just call this test vector. Are we going to extract just CBD and just ID from these elements of this vector, from these strings? This too far off. Hold on. What were some of the functions that we had that could take a string from other strings? Maybe just a pattern or based on some other information. Well, we had a few. A few that we had were things like string split fixed, which would like give us back a matrix. We had string remove and string extract. But in order to pick from those three, how would you put into words what you want to do to get just these elements that you want from these strings? Like without computer jargon or anything, what would you say? Mm-hmm. Right. Okay. That's a good start. We have character data, and we want to get rid of the numbers. So let's say that we want to string remove this mess in the back here. So we could say string remove our test vector. And what we want to do is get rid of, let's say, start from the front of our string. And we want to remove a give me a second. We could say that we want to string remove the dash, and then we'd have down here CBD11, IDO1, and then we could just say anything after the dash, like this.
The dash is minus. Or what does the dash mean?
This will remove this part. And then the dot matches anything. And then the asterisk is however many things that match after. So this could be one of our options. I'm trying to think of a way that this would break. I feel like it does a pretty good job. Let's say that we wanted to just, if we had put into words that I want to break up the string into two parts, and then only keep the first one, we could say something like string split fixed, and we would say our test vector, and we're going to split based on the hyphen that's in between the thing that we want and the stuff that we don't care about. And we'll break it into two parts. And what happens here is we'll get a matrix that has the first elements in one column and the second elements in another. And we could, interestingly enough, just keep only our first column there, and it would return to us a vector with the elements that we want. I'm trying to think of another way we could put this into words. Let's say we only want to keep the letters in the front. Like we only want to keep those letters. And we haven't really talked about the numbers or anything. We just want the letters in the front. We could say string extract test vector, and then let's see, how would we write the regex for this? We're going to start at the beginning. So this is going to say, look at the front of our character string. And then we don't really have any strong expectations about what the letters are going to be. So we could just say A to Z in these brackets that just says, look for anything that matches in between the length A to Z. And then we could just say star, which will keep matching as many times as there are letters that match A to Z. And it will stop when it runs into a hyphen. So when we run this, we'll get basically the same answer. We get functionally the same answer. So any of these things would be a way that we could have our region extract function work. Do y'all have any preference for which one we're going to run with for the rest of class today? All right, let's go with intuitive. So our region extract function is going to take a vector x, and it's going to, we're going to replace our text vector with that vector x that gets input. Let's see. We could then try it out, region extract, and we could say our test vector. Oops. Looks like it's working just fine. But for best practice, we probably want to actually put this in return. And the reason we want to do that is to just make it very clear about what's going on in our function. In the case of this function where there aren't a lot of steps or anything, then the last thing that happens in the function is in fact what we wanted to output, but that's not always the case. And let's say we want to return to this function and change it in some way, we still have a sense of what it's going to return to us when it's run. So. Let's see. Run region extract this. It should give me this. So great. first question and we can move on. The next question says, then on station data and trip data, make new columns called terminal region, to station region, and from station region using the region extract function. Okay. We're starting with our station data, so I'm just gonna copy this, or I should copy this one. And I'm going to make some new columns. What's our function for making columns? Mutate. I'm actually going to use this so that we can see it all in one line. Okay, so we're going to overwrite our station data with the station data and then mutate. And what is it that we need to mutate? We need to make new columns called terminal region, to station region, and from station region. So I'm going to go to the console and run glimpse on our station data. And we'll see that we want to make terminal region based on our terminal column. So we're going to mutate terminal region is equal to region extract. Run that. And now we can look at the glimpse again. And we'll see that this Belltown 01 code got turned into just BT, or CBD 13 got turned into just CBD. We're going to want to do the same kind of operation, but on our trip data. So I'm also going to go to the console and run glimpse on that. Expected. I see. And what do we have here? We have our from station ID and our to station ID, which we'll be using our region extract function on. So we're going to have trip data and then assign it trip data and then mutate our to station region. It's going to be equal to our really nifty region extract function that we made. And it's going to take the to station ID column as its argument. I'm going to put a comma here and jump to the next line so that I can make the from station region column. The from station ID column. Now we run glimpse data list trip data. We'll see that our from station ID is the same as our from station region without the code at the back, and same goes for our to and to. Okay, do we have any questions about this process, about how we made these columns and got here? Nice to have a projector that works. Oh, actually, can y'all see? Should I turn off the lights? I didn't even think about that. Okay. Okay, how are we looking? Are we good to go on? Okay. So our next section is identifying rainy days. Here it says the events column in data list weather data mentions if there was rain or thunderstorms or fog, etc. On some days, you can see multiple weather events. Add a column to this data frame called rain that takes the value rain, if there was rain, and no rain otherwise. You'll need to use some string parsing since rain is not always at the beginning of the string. The function string detect may be useful here, but again, if you're running short on time, just look for rain at the beginning using string sub as a working but imperfect approach. Then convert rain variable to a fact. Okay. So first things first. Let's see. I'm just gonna copy this from up here. And look at this events column by using count. Actually, I should also say P. And what we'll see here is that 141 days, we had some rain. 205 days are missing. Some of the days have fog first, then rain, and others have rain first, then thunderstorm, or rain first, then snow. Okay, so we want to create a new column in our weather data. So I'm going to follow a similar procedure as our last chunk by saying assign to our weather data the weather data, and then mutate to make a new column. And it told us what kind of what the name of the column should be. It's just going to be rain with a capital R. So rain is going to be equal to what? It says use string detect, but we also wanted to return to us the word rain if there was rain and no rain if there was not. How might we go about this? If else? Yeah. Oh yeah. So we can start with if else. What should we give to the if else statement? A variable. Yeah. One of the things that our string detect function will do is it actually returns trues and falses, which is exactly what if else is expecting. So we could say string detect our events variable, and if it has the word rain, return a true, and if it doesn't, return a false. Note that after this, we can hand to the if else the conditions of our trues and falses. So we could say, I'm going to actually bump this to another line just so it's easier to read. Our rain is going to be equal to if else the string detect in the events column rain, and then if that's true, return rain, and if it's not, return no rain. Yes, if we check if else by using the help function, we'll see that it's if else test. The first thing will be yes, second thing will be no. You can also specify, like we could say like no equals this if we wanted it to be in a different order. Okay, I'm going to run that. And then I'm going to say, I want to check if it's working how I expect. So I'm actually just going to copy and paste this thing from up here. And I'm going to say events and rain here. And we'll see that when our events column said rain, well, first, when it was missing, it also returned missing. So that's something to note. But also when our events column was rain, our rain column was rain. When our events column was fog, our rain column said no rain. So that seemed to work, but we need to figure out something to do with these NAs. So what do y'all think? How do we get rid of those NAs? Or maybe just get it to say when something's missing that it actually means there wasn't any rain. I'm sort of preferable to that approach, to saying that when it doesn't have any weather, that it probably also means that there was no rain. I think that's a pretty defensible assumption. So what I'm going to do here is I'm going to put a comma after our if else. And I'm going to say rain is going to be equal to, again. So I'm going to overwrite our rain column with some more information. So I'm going to say rain is going to be equal to another if else. And this will say is.na in the rain column. Say no rain. Otherwise, rain. Actually, this isn't supposed to be close. My bad. Otherwise, just tell me what's in that column already. And now when we run this, our missing is coded as no rain. I tend to do this quite a lot in my own code, is sort of overwrite my own columns with information in those columns. And I try to keep them in the same mutate call so that I can follow the steps that I took in doing so. I feel like this is a little bit counterintuitive, so I'm going to explain these steps again. So first, we made the rain column, and we said if else, we detect in the events column the word rain, make our rain column also say rain. And then if it does not say rain in our events column, return no rain. And we did that. And then we noticed that string detect, when it sees a missing, doesn't return a true or false. It just returns missing. So what we did was we overwrote our rain column by saying, if else, there's an NA in our rain column, write no rain there. Otherwise, just keep the rain column as is. So for all the rows that were not NA, it's just going to keep the column the same. Okay. Are we cool there? Do we have any questions? Let's move on. Next, we're going to merge the rainy weather and trips data. So you have a bike station, region information now, and rainy weather information. We're going to make a new data frame called trips weather that joins our trip data with the weather data by the trip start date, so that the rain column is added to the trip level data. just the rain column, please. None of the rest of the weather info. So we're going to only be keeping our rain column as something to join on top of our trips data. You may need to do some date manipulation and extraction as seen in week 5 slides to get a date variable from the start time column that you can use in merging. Okay. Kind of a mouthful there. Let's see what we got to do. So we know that we're going to make a new data frame called trips weather. And it tells us that we probably are going to join our trip data and weather data. With that in mind, I'm going to see what our trip data has. I'm going to just get a glimpse of that. And also our weather data. Okay. So it says we're going to join trip data with weather data by the trip start date so that the rain column is added to the trip level data. Okay, so let's look at the trip data first. We'll see that the start date is not yet its own column. In fact, what we have here are start times that include things like it was 10:30 when someone got on this bike, or it was 10:48 when they stopped. So what we'll need to do is get rid of those times in order for us to join by the date, because the weather data, by contrast, doesn't have the times, just has what day it was. Yeah. So let's start with the thing that it wants us to make. It wants us to make the trips weather object. So we're going to assign to it our trip data. And then let's see. We want to convert our start time to a date variable. So our start time right now is actually a date time variable. We want just the date. Does anybody know how we might convert this column type into a date? That's how we took something that was a character and turned it into a date. But let's say that we want to make the date column. It's actually I realize I'm phrasing it in a way that makes it seem like it's more difficult than it is. So when we want to convert something that's convert a variable type to a different one, historically, if we wanted to change something like the number 3 to 3 in quotes, how would we have done that? As dot character, and when we ran this, we would get the 3 in quotes. It's actually, there's a base function in R that does the same thing, but for dates. So we can say as dot date R start time column. And now if we look at trips weather data, a glimpse of that, we see that start time is, our first one, for instance, is October 13th, 2014 at 10:31. And down here, we now have a date column called date that doesn't have the time. It just is the day. There is a dplyr version of this called as underscore date that has some special use cases, but more often than not, as dot capital D date is sufficient. Okay. We also wanted to join our weather data by that date column. So I'm going to put another pipe here and say, and then we're going to left join. Here, left join is just a preference. We don't necessarily have to left join, but I typically tend to just use left joins and think in terms of joining this thing that we've already piped and already been working with something else from the right-hand side. And we're going to give it our weather data. But since we don't really want any of the rest of the weather info, we can, within the function, manipulate this data frame. So we could say, and then select. Now, what do you think we need to select? We know that the rain column is there, but do we need anything else? Something to join with. Because right now, if we had just the rain column, we wouldn't be able to join our two data sets together. But we're going to also select the date, which I think in that data set is also just capital D date. I'm going to put a comma here, and we're going to say by equals date. I'm going to run that, and I'm going to see what it looks like by running glimpse. Weather glimpse. And what we have are trips, what time they started, what time they stopped, some information about the bikes. But down here we have the date and whether or not it was raining that day. Okay, do we have any questions at this stage about how we got to this place? I leave this in here partly so I can remember the way that it works, because let's say that up here we called this trip date instead of capital D date. And then what we would have to do down here is say trip date equals date, with our thing that's on our left-hand side equal to the thing that's on our right-hand side, in order for him to see them as the same kind of column and join by it. And so you can actually, instead of doing that, like say if they're both named the same thing, we could say, I think that you can just say date and it works fine. You can put it in just quotes though. But I tend not to do that and put them in the concatenate, just so I can remember that this is the thing that I'm joining on. And right now I think that they're the same column. Okay. Any other questions? We'll move on. Great. So next we're going to make a summarizing and plotting function. Now for the grand finale, it says, write a function, daily rain rides, that takes as the input a region code. Our region code will be things like CBD or UW, and also a direction, which indicates whether we are thinking of trips from this location or to a region. And inside the function does the following. First, it's going to filter the data to trips that came from stations with that region code or went to stations with that region code, depending on the values of the direction argument and the region code argument. For example, if I say region code equals BT for Belltown and direction equals from, then I want to keep rows for trips which from station region is equal to BT. So that's going to be one of our first steps. What else it's going to do, what it's also going to do, it's going to make a data frame called tempdf with one row per day, counting how many trips were in the region code that was specified in the function and going the direction that was specified in the function. This should have columns for trip starting date, how many trips were that day, and whether or not it was raining or not that day. You'll want to use group by and summarize. There are other ways than using group by and summarize, which we'll see. The third thing is we're going to use the tempdf, our temporary data frame, to make a ggplot scatter plot using g_on_point with trip starting date on the horizontal axis, number of trips on the vertical axis, and points colored black for days with no rain and deep sky blue for days with rain. Make sure the legend is clear and that, the x-axis is easy to understand without being overly labeled. You can control this using the scale x date modifier for ggplots. The title of the plot should be customized to say which region code is shown and which direction is analyzed. Things like daily rides going to South Lake Union using pace 0. Feel free to use whatever theming you like on the plot or other tweaks to make it look great. And it returns a ggplot object with all its layers. I have created a skeleton for this function. Fill in your code as needed and remember to set eval equal to true in the chunk after you've written the function. Okay, then test out your function. You're going to make 3 plots using our function. This is quite a lot. Let's get started. So we know we're going to be starting in the body of our daily rain rides function. Okay. We know that our function is going to take a region code as well as a direction. So anything that we do is probably going to include those things. What was our first thing we wanted to do? Filters the data to trips that come from stations with that region code or to stations with that region code. Okay, so it says it filters the data, so we already are kind of thinking that we're going to be using the filter function. Let's make a tempdf. We want it to filter, so we're taking the trips weather data that we made in the earlier question, and then we're going to filter. But we have a problem, which is that, let's say we look at the glimpse of our trips weather data. Our to station region and our from station region are separate columns. So we would have to say something like to station region equals our region code in order to filter. In order to filter our data frame. But what do we do if it's a from? If they specified from? Do we have any ideas about what you would do? So we're making a data frame with our trips weather data, but the person who's using the function can specify the direction. And the direction can say to or from. And here we filter to just the to region. But what happens if someone says from, or if they want the from information? What do we do when there's like a specific case that we want to set aside for inside of a function? It is an if-else statement. Okay, so the way we'll write this is we'll say if direction equals 2, then we're going to do an opening squiggly brackets, and then we're going to do a closing squiggly brackets. So if direction equals 2, run this. That's what we have so far. But then, if it doesn't, we'll put this in squiggly brackets itself. But we might not want to just use else to make our other information. We probably also want to put another if statement here. So if direction equals from. Okay, are we following? So if the direction equals 2, run this. Else, if direction equals from, we're going to run this. I haven't written what this is going to say yet, but it's going to be tempdf, assigned to it trips weather data, and then filter from station region equals region code. Okay, I'm actually going to put a space here, and a space here for some legibility. Okay. Now that we have that, I'm going to talk a little bit about why I did this. So the if else format is really great for when you have like one specific case that we want to make explicit about. In this specific case, do this. But if we didn't also write if direction equals from, and just left it like this, this would also work. Okay, but the problem would be that it would work anytime someone didn't write direction equals 2. And so let's say that they misspelled 2, it would just give them the from data. And so we don't want that. So that's why I said if direction equals from here. And this case is maybe not necessarily the right one for that, because people aren't going to misspell 2 very often. But that's how you would have it, not just put everything that wasn't the 2 version into the from one. Okay. So after those things are done in the body of our function, let's see. Yeah, so filters the data from stations from the region code, or went to 2 stations with the region code. So we've done that. Next, make a data frame called temp df with 1 row per data, counting how many trips were in the region code going a direction. This should have columns by starting date, for trip starting date, how many trips were on that day, and whether there was rain or not on that day. You'll need to use group by and summarize. This should be a want. You don't necessarily need to use those, but we're going to make a temp df again, But we're just going to overwrite a tempdf that we've already created when we filtered down those rows. And then we wanted the number of cases per day. We could use, if we wanted to count how many times there was a bike ride per day, what function will we use? You got it. So we'll count the date and the range. So let's do that. Trying to think about how would we check this. So I'm going to try to check this by saying UW here. So I'm assuming that if somebody used our function as it's already used, they said from and UW, and I've run it inside of here to check my tempdf to see if it works. And now if I look in the console, I could say, yeah. So what we have is the date, whether or not it rained, and how many bike rides left from UW. So I'm going to go back in here and just change this back to region code. And it looks like we have all the columns that we need out of the tempdf. We have the date, whether or not it rained, and how many bike rides there were. The next thing that we want is a ggplot, am I right? Yeah, it uses the tempdf to make a ggplot scatter plot with trip starting date on the horizontal axis, the number of trips on the vertical axis. Okay. So we'll have a ggplot. We're going to just load the ggplot library here just for people to remember that's what's going on here. But we have a ggplot. Our data equals tempdf. And our aesthetics are going to be the x-axis is the date. The y-axis is the amount of rides, which since we use count, we know it's just n. And then we're also going to say that the color is equal to our rain color. And then I think it tells us we want a scatter plot, so we want to use geom points here. So we can use geom points. Great. So it seems like the ggplot populates and that the bike rides probably fit the structure that you might expect. That in January, I ain't getting on no bike. Come on now. But in July, yeah, I'll meet you down somewhere. Let's go to Golden Gardens or something, you know? Okay. I'm going to kind of quickly go through some of these things that are just like aesthetic for our ggplot in the interest of time. So our Y label is going to be number of rides. Our title is going to be, oh, that's right. They wanted to paste 0. Let's say daily rides going. I'm going to say comma. I'm going to say the direction. So this is going to be what they're putting in the function, comma. I'll just put a space here. Region code. That's right. Try to scoot this so that it's all on one line. And minimal. There's something else. The color. To do the color, we're gonna do scale color manual. And typically the scale arguments that you can give to a ggplot will determine your what is the name of it? Legend. So I'm going to say the name of our legend is going to be equal to weather with a capital W. And then I'm going to say values is equal to, and when it's no rain, I want it to return black. And when it is rain, return deep sky blue. And I think that should be everything. Oh yeah, directions not found. But I'm going to create this function. And then I'm going to head down here to the other chunk that says test out your function, make 3 plots using daily rain rides. So I'm going to say daily rain rides, and then my region is going to equal to South Lake Union, and our direction is going to equal to from. Now I get this nifty little, going from is missing a space. So I want a space here. I see. And we got to run the function again so that we can make sure that our function has this space. We needed to do it 3 times. Let's see. We can also, we know that it's region code, and then this is supposed to be region code. It's weird that it read it not. Sorry, I just really confused myself by the way that region got read there. We gave it an argument that it already. I think what happened for the people who are watching at home and who are like, wait a second, that shouldn't have made a graph. When I said region equals SLU, then the thing just took whatever the first argument was, even though this was misspecified, I think. Anyways. You could use international districts. 2. This is making me think that we probably want some other information in our ggplots. So I'm going to actually go back up here and add a geom smooth, just because I'm a little bit confused about the data sometimes. I'm going to say method equals LOS, and the LOS one also needs something formula. And our formula is going to be equal to y by x. I'm going to do that. And then when I head back down here, this, which just has sort of a general hard to eyeball combination, will now tell me that that's like true, that the black line and the blue line were pretty similar for how often people were riding the bikes, and that it seems like it's more of a regional time effect, which is like more people were riding because it was warmer out, rather than more people were riding necessarily because it was raining or not. And then one more example, maybe leaving UW. So it looks like generally there's more people who are riding bikes because it's not raining, but we also live in Seattle. So like, who cares? What are you gonna do? I gotta get home. And that's it. That's the homework. So I'm gonna stop the recording. Wow, the last homework that's not optional.